Oh, and it's so. Oh, yeah. I need to. So you should. That's what. I get that. That's the
All right, guys, page 7. So
26, yeah.
we're beginning, guys. So we're beginning to look at some of these what we call these tests for convergence, and based off of different types of series, we're able to determine whether these series will converge or diverge. Again, converge just means that if we add up all these terms, that it's going to head towards a real number, versus where if we add up a bunch of terms, it ends up headed without bound either to infinity or to negative infinity. Today we're just going to cover geometric series. Tomorrow we have a bunch of them that we're going to kind of consolidate together into one section. It's the nth term test, piece series, and integral test. So, after today and tomorrow, we would have seen the majority of it. Actually, between today and Wednesday, we would have seen the majority of all the different types of series and different tests, and then we'll begin to put it all together next week. Okay. And let's see here. So our calendar here, we're just going to spend a majority of next week reviewing, and then our quiz, 10.1, 10.6 quiz will be after the break. I'm going to cover the next section on Wednesday, so we're not having a quiz the day we get back, and then I'll have a help session Wednesday and Thursday, Wednesday afternoon, Thursday morning, and then we'll take the quiz after break. Okay. All right, so all right, so what is a geometric sequence? Geometric sequence is one in which the same number is multiplied to each term to get to the next term in the sequence. You can either be multiplying by a number greater than 1, or it can be multiplying by a number less than 1. You can think of it as dividing by 2, or think of it as multiplied by 1/2. So we're always going to think in terms of multiplication, even though we could think of it as dividing by a number when it gets smaller. The number you multiply is called the common ratio. Or denoted by R. Okay, so the nth term of a geometric sequence, with first term a sub 1 and a common ratio R is given by, so a sub n is going to be a sub 0 times R to the n. Or we can start off with the first term, a sub 1 times R to the n minus 1. Or I can start at the subsequent term and then multiply by R to the n minus 2. All right, just to kind of show you how these can work here. Let's say we have a geometric sequence 3, 6, 12, 24, 48. To find the common ratio, we can divide any subsequent or any term by the previous term, and we should get the same ratio every time. So here, 6 divided by 3 is what? 2. 12 divided by 6 is 2. So it needs to be the same ratio every time. Okay. And we can double check that. So here, if I do a sub n divided by a sub n minus 1, it doesn't matter which one it is. As long as I do 1 divided by the previous one, I should always get a consistent ratio. And if I did 6 divided by 3, I get 2. If I did 12 divided by 6, I get 2. So the one that we're going to use the most often is going to be this one here, where a sub 0 just represents the initial term, and then times the ratio to the nth power. I'm sorry. This is the previous one. This is the one before the first term. So let's do the one that's more obvious first. This is a sub 1 times r to the n minus 1. So my a sub 1 is going to be 3, and my r is 2 to the n minus 1. So this will do the job of telling me each of the terms in this sequence. So if I want to find the first term, I can plug 1 in. So 1 minus 1 is 0, 2 to the 0 is 1, 1 times 3 is 3. That gives me the first term. I can also do a sub 0, meaning the term before the first term. So what's the term before the first term? 3 over 2, right? If I'm multiplying by 2 to get to the next term, I can divide by 2 to get to the previous term. So I can also find the value in each sequence, in this sequence, by doing the previous term times r to the n. This will also get me any term in the sequence if I just give it an n value. Right. Likewise, I can start at 6. Okay, I'm going to skip number 2. Number 2 is the same process as above. Let me go down to, let's say we have a series in the form of a times r to the n. And if I want to list out the terms in this series, I'm just going to follow what the rule says. So I'm going to start at 0. So 0 in for n. R to the 0 is going to be just 1. So it's a plus. And then my next term would be a times r to the first power. Next one will be a times r to the second. So on and so forth until a times r to the n. Whatever my nth term is. It could be infinity, it could just be some value that's that's a large value. Okay, so this is really the convergence test that we're going to be using here. A geometric series with ratio r will diverge if the absolute value of r is greater than or equal to 1. However, it will converge if the absolute value of r is less than 1. So if it's equal to 1, it's not good enough. It will still diverge. That line is at 1. It needs to be less than 1 in order for my series to converge. So the sum of the series is going to be a times r to the k over 1 minus r. So in other words, the easier version of this is just going to be a sub 1 over 1 minus r. So sum of a geometric series is a sub 1 over 1 minus r. This is what we're going to be using here. So there's two things that we can do with geometric series. We can first determine if they're just asking for whether it converges or not. We just have to figure out, is the ratio less than 1? If it is, then it converges. But if it's asking for the actual sum of the series, we have to. We can only do this for a converging series. So, but once we determine that the ratio does fit under this category of less than 1, then we can actually find the sum of that series. And a sub 1 is just the first term of the series. And then AR to the K is going to be the first term in the series. So basically, it could be starting at n equals 0, it could be starting at n equals 1, could be starting at n equals 2. Whatever that first initial value is, if we plug that in, that's going to be the first term. Whatever that K value is inserted into the rule of sequence is going to be our first term. Sometimes a problem may not be quite in this form of a times r to the n. And so we want to try to get it into this form so that we can quickly identify the ratio, so they can quickly decide whether the ratio is less than 1 or greater than or equal to 1. So let's look at number 1 here. We have the summation from n equals 0 to infinity of 3 over 4 to the n. Can I rewrite this in the form that is a times r to the n? What would that look like? Yeah. So I think it really helps if we can get it into that form. It's easier to identify, oh, this is obviously a geometric series. I'm multiplying by 1/4 every time. And having that r there allows us to quickly identify whether it converges or diverges. Okay, so the absolute value of r is still positive, but even if it's negative 1/4, that will still fall under less than 1, right? We're looking at the absolute value of r. If it's negative, that's not going to influence whether we have, right, so make sure we always just look at the absolute value of r. So here, my ratio, absolute value of r is 1/4. Okay, so will it converge or diverge? Converge, right? So we know that every term is getting smaller in a way that we know if we add up all the sums, it's getting small fast enough where we're actually able to get an actual sum. Even though we're adding infinite number of terms, there is a ceiling that we're headed towards. Okay, so there's two pieces that we need. We need a sub 1 and r if we want to find the sum. Yeah, so the direction, yeah, so that summation just means we are asking for the sum. What is the sum of the series? To find, we already have r is 1/4, and a sub 1, we got to find the first term. So how can I find the first term in this series? Plug in n equals 1. Plug in n equals 0. So wherever they start off, that is going to be our first term. It could be n equals 1, it could be n equals 0, it could be n equals 3, but we always want to pay attention to where that starting point is. Okay, so we're going to plug 0 in this case into the rule of sequence. So if I plug 0 in, 3 over 4 to the 0 is equal to what? 3, yeah. No, if r is greater than 1, then we just stop and say the series diverges. There's nothing more to do. But if it converges, then we can actually get this down to a number using this formula. Yeah, so this sum formula is for converging series only. No, no, we're plugging n equals 0 to figure out what the first term is. Yeah, we're just trying to find a sub 1. We've already established that we have a converging series. Let me write that here. This is a converging series. Now our job is to figure out what the sum is actually. Okay, so 3 over 4 to the 0 equals what again? 3. Okay, so I have my a sub 1. I have my r is equal to 1/4. Now I can just put it into my sum formula. Okay, let's do some cleanup here. This is not too bad to do by hand. 1 minus 1/4 is 3 divided by 3/4, the same thing as 3 times 4/3, which is equal to 4. So the sum is 4. Even though we're adding infinite number of terms, the terms are each term is getting small enough where if we add up infinite number of terms, it will just hover close to 4 and it will just get closer and closer towards 4. Okay, number 2, it doesn't quite look like it's easy to identify what the ratio is. So whenever I see kind of like this messy expression, I'm just going to start breaking it up and then putting it back together in a way that hopefully will eventually look like this form. Okay. So I'm going to just start playing around with this expression. So 3 to the n plus 1 can be separated into what? Yep, so good. 3 times 3 to the n. I'm going to say 3 to the n times 3. Yep, they're the same thing, okay? And then divided by 4 to the n. Right, can I rearrange this in a way where I can see the a and I can see the r and I can see the n? Yeah, so I can rearrange this, right? Make it 3 times 3 to the n over 4 to the n, and then I can continue to clean this up by, I guess, pulling that n outside a set of parentheses and make it 3 times 3/4 to the n. All right, does this sequence of steps make sense? Okay, so we can rearrange it in a way where now it's a lot easier to work with, right? What's our ratio? 3/4, right? Will this converge?
Yes.
Yes, it's less than 1, right? Okay, so we know it's converging series. We want to find the first term to get a sub 1, and then we can use that r to get our sum. Okay, how do we find a sub 1?
Plug in n equals 2.
Yeah, n equals 2. So whatever n value they give you, that is going to be that's how you're going to get your first term. Don't assume that it's either 1 or 0. They always have to tell you how to get to that first term. So if I'm going to plug in 2 and for n, you can plug it into any of these variations. I'm going to do this last one here. So a sub 1 is 3 times 3/4 to the second power. So I get 9 times 3 is 27, 27 over 16. That's my a sub 1. Okay, so I'm just going to put it into my formula. So 27 over 16 divided by 1 minus r. My r is 3/4. 1 minus 3/4 is 1/4. Divided by 1/4, the same thing as multiplying by 4. This is not too bad. We can reduce, make it 27 over 4. That's our sum. That's our sum of this infinite series, geometric series that we know will converge.
What? 7 over
27. 3 squared times 3. Let's see.
Okay.
Is that right? Yeah, so 3 squared is 9, 9 times 3, and then 4 squared is 16. Yeah. Okay, let's go to next page. Okay, for what value of r does the infinite series 17r to the n equal 23? So, I'm sorry. Okay, so let's put everything together here. We know our sum formula is a sub 1 over 1 minus r. They're telling us it equals 23, so we know it must be a converging series. Can I figure out what a sub 1 is?
Yes.
I can plug 0 in for n. R to the 0 power is going to be 1 times 17 is 70. So even though we don't know what r is, we're able to use that to help us get to our a sub 1.
Can R be 0 or no?
No, r cannot be 0 because sorry, I think the understood idea is that if it's going to be a geometric series, our absolute value of r has to be between 0 and 1. Yeah, because if r is 0, then it's no longer a geometric series. That's right. That's right. Yeah. Okay, so now it's just the equation that we can put in and solve, right? Replace s with 23, replace a sub 1 with 17, and algebraically, we're just going to solve for r. And cross multiply. Okay, number 4, calculator active. It says if f of x is equal to sine squared of x over 3n, then f of 7 is equal to. So basically f of 7 means if I plug 7 in, this is my geometric series. It's asking for the sum of this geometric series, right? Basically what this is asking for, because f of x is the summation of all these terms. And we can consider this a geometric series. And we can treat R as everything before that n. A would be whatever 3 plugged in here would get us with that 7 in place. So let me just show a couple of steps here. So f of 7, first of all, we know f of 7 is the sum of this geometric series. When x is equal to 7. Okay. It should be a 1. So let me write this a different way here. What if I wrote it this way? This is, sorry. So this is my ratio, right? My ratio, this is my R to the N. My R includes that squared there, right? So that's my ratio. Okay, so I'm going to just show that R is. And then my A sub 1 is just replacing N in 3 or 3 in for N and then getting that A sub 1 value. So A sub 1. Which is the same thing as sine of 7/3 raised to the 6th power. Okay, we can use our calculator. We can make sure we're in radian mode. My R is just sine 7/3 raised to the 2nd power. So now we have everything that we need, right? We have our A sub 1, we have our R, and then we can just put into our sum formula.
Anything on the calculator?
No, okay. Okay, we'll just work through as much of the classwork as we can together, and then whatever we don't finish will be your homework. Okay. All right, so let's look at number 1. Anybody still need number 4? Okay, so number 1, we have -7 over -3 to the n. And we can rearrange it in a way that feels more in line with that A times R to the n. Okay, so how can I rewrite this?
-1/3 to the n times -7.
Yeah, this is what I have. I'll put it up. Right, same thing. It just feels a little more familiar in terms of just lining up with what we want to use. Right. What's our R value?
-1/3.
Okay, -1/3. Will this converge?
Yes.
Yes, because the absolute value of R is less than 1. So we know we have a converging series. Now, even though we're testing convergence by doing the absolute value of R, the R value that we're using for the sum will be -1/3. Okay, so we're testing using the absolute value, but we're still going to keep that -1/3 when we plug in the value for R. How do I find A sub 1? Yeah. Okay, so just be careful. Don't assume that it's always n equals 1 or n equals 0. Look to see, they always have to tell you how to get to that first term. You never have to, it's never an understood value. And so if I plug 1 in for n, either one here, what's my A sub 1 going to be equal to? 7/3, right? Because -1 to the first power is -1/3. -1/3 times -7 is positive 7/3. Okay, so this is all we need to build our sum. Okay, number 2 should be pretty straightforward. Try number 2.
After this for this quiz, right? Excellent.
Let me tell you later. Okay. Depends on. Yeah, let me get back to you the next day or 2.
Okay.
My ratio is 1/3. That's obviously converging. My a sub 1 is just 1/3 to the 0 power, which is 1. So 1/1 minus r, 1/2 is 3/2. Okay, any questions with 2? All right, number 3. Number 3 says we have the summation of e to the nx. Let x be a real number with x less than 0. I'm going to rearrange it, make it e to the x to the nth. That way, this lines up more closely with what we want the ratio to be. Now, x is less than 0. So that could be like -1 or -0.1 or -2. What's that going to cause this number to be? Okay, which is going to be what? Less than 1, right? So we know that e raised to any e to the x, if x is less than 0, is always going to be less than 1, right? So will this series converge? Yes. Yeah. Right. What's a sub 1 going to be? Good. If I plug 0 in for n, 0 times x is 0, e to the 0 is 1. So the best we can do is we can write the sum, but we don't know what x is. We just know that it's less than 0. So we can just leave x in our sum. Okay, number 4. Let's see, what do we remember here? E is around what? 2.7, okay. And then pi is around 3.14. So what do we expect? Will this converge? Yeah. Yes, right. E over pi will be less than 1, but if it's pi over e, then it'll diverge, right? Okay. Okay, so we can plug 1 in to get a sub 1. We know e over pi is our ratio, and then we do our sum from there. We can't because e is has that n there. Right. Now, if it was e to the e over n to the n plus 1, then I can separate that times e to the n. I can pull that e over n out. But this is kind of stuck in as part of the ratio. Okay, let's try one or two more. Can we do number 5 and 6? Number 5 and 6 just requires us to kind of separate the terms and then put things back again with the R's to the end together. Yeah, just kind of split up and then rearrange again. See if we can practice doing that for 5 and 6. Mhm.
How do we know that base of 1 isn't equal to negative? It's because -1 instead of 0 is 1.
That's right. Anything to 0 power is 1.
So we have to be the -1 into 0, and that makes it positive, right?
Let's see, ask your first question again.
Never mind, I think I just talked myself. That's my answer, sorry.
Yeah, I rearranged 7 in a way where I see that I can merge that together to be -1/e, and that convinces me that's my R value.
For some reason, I was just thinking that to the 0 was negative.
Oh, no, yeah, still positive.
Yeah.
Yeah, still positive. Okay, but let me show number 6 first. E is 2.7, so we know 2 over 2.7 is safely less than 1. Converging geometric series, and we can jump into our sum formula. All right, so your homework is pages 8 through 13. It'll be the 10.2 classwork problems plus the AP practice. And I have all the worked out solutions on the website, so you guys can check your answers there. All right, can we get the phones?
It's depending on where. It would be
The number 6, would it be possible to leave it like with the?
Yeah, that's fine.
It's actually. So if you. If we had some. So it's whatever the sum of the next is. I'm saying that we just agree on the notion of. That's not. I'm just. Number 9, but I'm.
Wow.
Wait, like, are you a first or second generation South Asian? And see, I'm the second one. That's better than you. Are you thinking? I'm part of it. It's just. No, and I am.
So I would have my. It's okay.
Yeah.
Here's an interesting one. Yeah, so I just. No, don't. It's not right. This is like. See if Francis has. After we do. Yeah. Next, we understand. What happens? So basically. I mean, I know where I'm going. Well, no. I'm not wrong in the wording. If the button is worth funny.
There's so many technical.
So I'm saying.
Like, no, he did it in this more like expressively. Then we don't have a slow song. We don't have a single slow song. Like if this kid needs to.
Yeah, but.
We need to